Welcome to my projectbazaar.com.
Now we discuss about the product for FPGA implementation of hearing aids using stationary wavelet packets for denoising. Next we discuss about the abstract for the product. Digital hearing aids score over their along counterparts because of using advanced digital signal processing algorithms to compensate speech signal and improve the intelligibility of hearing impaired in noise environment. The general problem of noise reduction has been addressed in great depth by researchers who have investigated several speech enhancement algorithms and techniques for various noise environment to reduce the effect of background noise on speech intelligibility and overall sound quality. Speech enhancement methods include speech subtractions, mean square estimation, format based methods, discrete Fourier transform, discrete wavelet. The wavelet based approaches have become appropriate to the Fourier transform in the field of digital signal processing due to their multi-resolution capability. This application of wavelet transform based methods in designing hearing aids is found by early early based on our discrete wavelet transformation methodology. Wavelet approach is applied to further reducing the noise by expanding the series of implicitly filtered shift invariant wavelet packet basics vector. The implicit filter operation allows reducing the correlated noise while retaining low-level, high-frequency spectral components that are necessary for intelligible speech compensation for sensor neural impairments. The toughest changes for hearing aids designers is the implementation of devices which meet the requirement of hearing aids users like portability, low power consumption, noise reduction and intelligibility. Speech signal often the contained with noise which the present in variety of listening environment. This problem is of critical importance because background noise is partially damaging to speech intelligibility for the people with hearing loss and hearing aid users. The pre-processing step in modern digital hearing aids is denoised to estimate the signal in the band of interest from the available noisy signal without alternating it. Advanced in digital signal processing have allowed to adding the visual features to improve the performance of assistive listening devices like speech enhancement and noise reduction. Furthermore, process in the field programmable gate array technology, especially in for miniatured system application, facilitated the implementation of small, portable and high performance devices. In this paper, a signal processing core based on the stationary wavelet packet is designed for speech enhancement and denoising in hearing aids. The development of core is implemented for speech FPGA and to interconnect with the embedded microprocessor and related peripherals to form a complete system on programmable chip. Next we see the flow diagram for the product. The input speech signal are applied to our processing for speech denoising methodology. This speech signal to apply the MATLAB functions, then to add the noise signal using the MATLAB results, then the additive white gas noise to be add the input speech signal, then to this noise signal to apply the simulating designs. Our simulating designs mainly based on our digital oriented Xilinx blocks to design our simulating design due to the speech denoising methodology. These designs consume the signal decomposition and threshold methodology, then signal reconstruction process. The signal decomposition methodology mainly used to do downsamples and the low pass and high pass processing for signal decomposition method. The threshold methodology to apply the set of regions to the based on our the noise level processing, then to apply the signal reconstruction process. Then reconstruction process mainly used to do upsamples and the high pass and low pass filtering process for the signal reconstruction level. Then finally we display the signal denoising due to the digital based process. Then to apply the system generator, the system generator process mainly used to convert the VHDL code and to apply the generate the VHDL code for speech denoising methodology in Simulink designs method. This the Simulink design to be convert the VHDL code using the system generator process, then to calculate the simulation and synthesis results for due to the speech denoising methodology for our overall architecture process. Then to compare the speech denoise methodology compared to the real-time process and to modulate the Simulink based VHDL process. Finally, we see the output for the product. This product is combined for MATLAB and the Simulink. Then go to the Xilinx design. These are two software combined with our processing performance. Then we browse the input signal to combine with main M5 function. Then to add the additive white Gaussian noise and to add the amplitude noise for our input voice noise. Then we apply the noisy signal due to the denoise Simulink design. These Simulink designs to convert the signal decomposition and to thresholding, then to convert the signal reconstruction process, then to apply the results for denoise processing for Xilinx ISC project. This project to convert the VHDL code and to simulate our the denoise Simulink designs. Then go to the denoise conversion VHDL code for Xilinx ISC project. This project to simulate and synthesis result for overall project. This is our ISC project for denoise architecture. This architecture code for mainly used to converted into the Simulink design process. This process to select the our VHDL code, then to select this denoise process and to select the simulation, then the simulate behavior process, and we go to the implementation process. This implementation process due to the RTL and technological schematic diagram. This RTL diagram to represent the denoise IC design for required conversion of VHDL code process. This is the denoise icing process for required IC designs for overall architecture. This is the clock driver and buffer amplifier to generally designed for our VHDL process. This diagram mainly used to what are the logical blocks presented in denoise architecture results. This is the technology diagram. This technology diagram mainly used to what are the lookup tables and device utilization process mainly placed for overall IC architecture designs. Then we go to the design summary process. This design summary process to simulate the synthesis report for overall architecture process. This is our the device utilization process for lookup table and slices register. Then the flip-flop pairs used for overall architecture. This is the bounded input output functions for overall architecture designs. This is the timing summary for overall processing architecture. This is the minimum PD and maximum frequency for overall architecture. This is the path delay for 1 seconds. This is the latency time for overall architecture process.